So what's the condition for a map to be conformal? Well, if we've got a domain D in the z-plane, then if f of z is analytic in D, then that implies both ways that f w equals fz is conformal, is a conformal mapping in this region. Now, we also need that f dashed of z is not equal to 0, very importantly. Okay, so these two conditions, f of z is analytic in D, and also f dashed of z is not 0 anywhere in D, then the map is conformal in that region. So what happens if f dashed of z equals 0? Well, then we can still get a map, but things get a bit more complicated. It's no longer conformal, but the condition, what happens is that if we write it in a most general way, then if f dashed at z naught is 0, and all the derivatives up to, okay, well, I'll write if the apple dashed equals up to the nth minus 1 derivative. If all of those are 0, but the nth derivative at z naught is not 0, then, and this actually works, this even works for n equals 0, so the, for n equals 1. So this is for n equals 1, 2, and so on. So the n equals 1 case corresponds to this case here. So that's the ordinary case. But for other n values, for all n values 1, 2, 3, what happens is that if you've got a point z naught and your C1 and C2 coming out of it, and the angle here, then this angle theta will in general get mapped to n times theta if f dashed of z naught, well, okay, in fact for any point z naught this is true, because the conformal map is the case n equals 1. That means that the first derivative is not 0 at z naught. That gives you the conformal map. But if the first derivative is 0, but for example the second derivative is not 0, then the angle would be doubled, and so on.